Okay, so in question number 1, we see we have an algebraic function inside and then a power. So I'm going to do like the basic rules of derivation. Bring the power down. You got to write the exact same thing inside the bracket. And then you have to subtract that by 1. So that's regular derivation. But because of chain rule, because it's a composite function, we have to multiply by the derivation of the inside. If I derive 5x minus 4, that's just 5. Now I can simplify by multiplying the 5 times 3, so that's 15. And that is my final solution for the first one. For the second one here, this might look like a quotient rule question, but technically it's simple derivation using the chain rule. So before you can actually derive, you want to simplify by moving this to the top. So basically it's 3x plus 5 to the power of negative 4. Now I can derive the function. So if I derive this, I'm going to bring this number down, write the exact same thing in the bracket. If I subtract minus 4 minus 1, that's negative 5. And then because of the chain rule, I'm going to multiply by the derivation of the inside. So the derivation of 3x plus 5 is 3. Now I just want to simplify this. There's two simplifications we can do. The first one is negative 4 times 3, which is negative 12. The second simplification, I'm not allowed to have a negative exponent in my bracket, so I'm going to move this back to the bottom. It becomes 3x plus 5 to the power of positive 5. Okay, third question is a square root question. Again, before you derive a square root question, you should always simplify by converting to exponential form. So that's going to be 4x squared minus 9 to the power of half. Next, what you want to do is you want to derive this function. So I'm going to move the half to the front, write the exact same thing inside the bracket. And then if I subtract half from 1, it's negative half. And then after that, I'm going to multiply by the derivation of the inside because of the chain rule. So the derivation of the inside here is just 8x. Now again, I can simplify this function. There's two simplifications again. The first one, 8x times half, that's just 4x. And my second simplification, I'm going to move this to the bottom because it's a negative exponent and I'm not allowed negative exponents in my final solution. So this right here is my final solution for this question. And last, let's go to question number 4, which involves a cube root and a fraction. Again, this is just simple chain rule. It's not quotient rule. I'm going to start by just converting the bottom from the root to an exponent. So cube root is 1 over 3. Next, I'm going to move this to the top. So the exponent is going to become negative 1 over 3. Okay, now that I've done the simplifications, I can derive this with my chain rule. The first thing I'm going to do is move the negative 1 over 3 to the start. I'm going to write the exact same thing in the bracket. I'm going to subtract 1 from my exponent, so that's negative 4 over 3. And then I'm going to multiply by the derivation of the inside of the bracket. The derivation of 2x squared plus 6x minus 9 is 4x plus 6. Okay, now that I have this, I just want to simplify this again. So basically, the term that's going to be on the top is the negative. So negative, and then this 4x plus 6 is also going to be on the top. This whole term is going to move to the bottom because it's a negative exponent. So I have negative 4x plus 6. On the bottom, I have the 3. And then I have 2x squared plus 6x minus 9 to the exponent of 4 over 3, and that is my final solution.